Moving on from last week where our chords just intersected entirely on the interior or inside of a circle, we're going to have two other situations today. So this is day 2 of segment lengths in circles. So if you did start to take notes from last Wednesday, you may want to grab those so that you can finish them off today. So we have a vocab word first, and that is secant segment. So as of right now, the definition of a secant is a line that intersects a circle at 2 points. Secant segment is still a secant, so it's intersecting a circle in 2 points, but now it is a segment. It's no longer a line, so it has 2 endpoints. So that is what we see pictured down here. Let me highlight that in red since I wrote that word in red. Right here, from P all the way to R. That is an example of a secant segment. The part of the secant segment that is strictly outside the circle is called the external segment. So external means outside, so it's the part of the secant segment that is outside of the circle. So I'll highlight that in blue here. That would be the part from P to Q only. Okay. The other thing that's shown here in the diagram is a tangent segment. So again, as of right now, a tangent is a line that intersects a circle at just 1 point. We can also have a tangent that is a segment. So they specify that by putting segment on there with the tangent. So when we are in this type of a situation, and we have secant segments or tangent segments, we will be intersecting outside of the circle. So the first situation is when we have 2 secant segments, excuse me. Just like when we intersected on the inside, we had segments of the chord, we also have various pieces. We have the external segment, and then you have the inside part, which you could call the internal segment, but it's not officially called that. So you've got the external segment for each of the secant segments, and then you have the internal segments for each of the secant segments. So again, I highlighted those in different colors just so we can kind of see where we're pulling this information from. So this theorem says that if 2 secant segments share the same endpoint, which these do because they're intersecting, which is outside the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So you take this external segment, which in this case is EA, and you multiply that to the entire secant segment. So that's the red part and the blue part in this picture. So you kind of add those together to get the entire length. All right, and then you have the external piece of the other secant segment, and then you have the entire length of the other secant segment. So that's the green and the yellow together. Okay, so let's look at this with some numbers so it actually makes a little bit more sense. So in example 3 here, again, I'm going to highlight these pieces. Highlight them a little bit differently. We'll do blue the whole way through. Green, and then we'll do yellow the whole way through. Maybe that'll make a little bit more sense. So you take your outside piece, which for PR is 4, and you multiply that by the entire length. So the entire length would be 9 because 5 plus 4 is 9. For the other secant segment, you take the external part, which is 3, and you multiply that by the entire length, which would be x plus 3, because you need to add them together to get the entire length. Okay, and then you would just solve that like you normally would back in pre-algebra and algebra. So 4 times 9 is 36. Distribute on the other side, and you get 3x plus 9. And then you just solve that right like normal. So subtract 9 from both sides, and you get 27 equal to 3x. Divide by 3, and you get 9 equals x, or x equals 9. So that would be equivalent to option D here for the answer. For example 4, again, if you want to pause the video, feel free to do that and then come back, see if you get it right. I'm going to walk us through it here in just a minute. So feel free to pause if you want. Got the exterior part and then the whole thing. Then we've got the exterior part and the whole thing. So again, the exterior piece is 3, and we need to multiply that by the entire piece, which is x plus 3. Again, you have to add them up. And then we've got the exterior part, which is 4. We have to multiply that to the whole thing, which would be 6, because 4 plus 2 is 6. And then again, just solve like you typically would. And this is just a coincidence that it happens to be the same value as example 3. Okay, the other situation that we may have is when you have a tangent segment intersecting with a secant segment. So with the secant segments, you use the outside piece times the entire length. With the tangent segment, you may notice that you only have an outside piece. Okay, so because you only have an outside piece, you have to use that piece twice. Okay, so that's why it says that if a secant segment and a tangent segment share an endpoint outside the circle, the product of the lengths of the secant segment and its external segment, so you're still taking the external times the whole thing, that has to equal the square of the length of that tangent segment. Because again, you have 2 pieces. When we were inside, we had 2 pieces we were multiplying with. When we were outside with 2 secant segments, you had 2 pieces you were multiplying. So we still need 2 pieces. So again, because the tangent segment only has that outside piece, you're going to use it twice, which is why we square it. So again, let's look at some examples down here with actual numbers. So we've got a tangent segment here, 16. So we're going to be using 16 squared. And we've got to equal that to our secant segment. So the outside piece is x. And I have to multiply that by the entire thing, which would be x plus 8 if you add those together. Let me highlight that. Okay. So now we do need to distribute on the right-hand side. So x times x plus 8 would give us x squared plus 8x. On the other side, we have 16 squared, which will give us 256. And again, you may remember from last week or from Algebra 2 that before you go to solve any quadratic, you have to have it equal to 0. So I'm going to subtract my 256 so that everything's on the same side, and then it's equal to 0. Now, at this point, I'm just going to have you stop. I'm not going to expect you to use the quadratic formula or to remember how to factor at this point. So you will see on the practice it tells you just to set one of these up. This is what I mean. Just multiply it out, get it in standard form, and just leave it there. Don't worry about going any further from that point. In example 6 here, we have a tangent segment, 24. Because that's a tangent segment, I need to square it. And then we have the secant segment. The external piece is 16. And I need to multiply that by the entire thing, which would be x plus 16. All right, so we've got 24 squared, which is 576. And then I need to distribute on the other side, so 16x plus 256. And then we solve that just like we typically would. So we'll subtract, get 320 equals 16x. And then if you divide, we get 20 equals x, or x equals 20. But for this one, if we look carefully at these directions, it wants to know the length of AB, which is just a piece of this green one. AB is just this guy. So if I plug 20 in there, we will get that x is 20. So AB is 20. Example 7, I actually did for you last week. That is where your chords intersect on the inside. So I'm not going to make you do that again. So we're going to jump down to example 8. Again, this would be a good time to pause the video, try it on your own, and then come back in and see if you got it correct or not. Hopefully you were able to get a value of 13 for x in example 8. Example 9 is a good example of one that you would just need to set up, multiply it out, get it into standard form, and then just leave it. Again, I'm not going to make you factor or use the quadratic formula here. For example 10, again, you would just be setting this up, multiply it out, get it into standard form, and then again, call it quits. Do not need to factor, do not need to do the quadratic formula at this point. Example 12, I'm going to walk you through together. Again, if you wanted to stop the video, you could. Just a little application here. So suppose the space shuttle is positioned at point S, which is 150 miles above the Earth. What is the length of ES, which is the distance from the Earth to the shuttle? The radius of the Earth is about 4,000 miles. So we're trying to figure out this distance right here. So this is a tangent segment. So I know that that distance needs to be squared. So that is x squared. For the other distance, this is a secant segment. So I know that the external segment is 150 miles. And then I need to multiply that by the whole thing. So if the radius is 4,000, that means the complete internal part would be 8,000 because that would be a diameter. And we need to add 8,150. So we're going to multiply this by 8,150. Okay, so this is going to be a very large number. So if I do 150 times 8,150, that gives me a huge number. That gives me 1,222,500. And we know that that equals x squared. So to undo the power of 2, you square root. So that tells me that the distance from the Earth to the space shuttle is approximately 1,105.67 miles. Always include units. If you have any questions on anything, please don't hesitate to reach out. Hope you guys are doing well.